you are here and you were very quiet, but when we end the lesson, that's when I saw your comment. I was like, ah, so it's also on the lesson. Wow. Okay. So on electric circuits, guys, it's very important to know the difference between an ammeter and a voltmeter. You need to know how to define them. That is not something they can ask on an exam, but if you know the difference, you'll be able to understand the whole concept. So an ammeter, this one, what do you know about an ammeter? So it measures the current strength, and then the voltmeter, it will measure the potential difference. So if I ask you to give me the resistance in series and also in parallel, so if I say, okay, let's do this, I'm just gonna draw for series down here. Let's say I have resistors in series. Now I'm just gonna give you a quick example how the resistors in series look like. So this will be my resistor. I'm going to call this R1. Then I'll have another one here. Let's call this guy R2. Then we have another one. Let's call it R3. Right. So now when I have this type of a circuit, we're going to say the resistors are connected in series. So each and every resistor here is going to have what? Is going to have a voltmeter. So a voltage, each and every resistor will be connected to voltage. Like this, we're going to call this V1, and then we're going to call this one V2 for R2. So the V2 will be for R2. Don't worry, you're going to understand why we need the drawing, because the some of the important things that we need to discuss. This will make sense now. So now, when these two are connected in series, at the end, you're going to have what we call the total voltage. Let's call this V total. Thank you, Surprise, for the rose. Let's call this V total. V total. And then, look at this. If that's my V total, you know what we're going to do. We need to understand that if the resistance and the resistors are connected so that there is only one path. You see the way these resistors are connected? There is only one path. So since there's only one path, what are we going to say about that? The current can take, there's only one path the current can take. Look at this. There's only one path the current can take. Can you see? Then we're going to say that then the resistors are connected in series. So this is my current, will move like that, in that direction. This is my current. So can you see that there's only one path to take? So these resistors are connected in what? They are connected in series. Okay, so now the current in series is constant. It's very, very important for you to note this down and say that your current, that's what you need to understand. The current in series is constant. So the current is constant. Right, the current will be constant, meaning that it will remain the same. So how do we find the V total? The total voltage. How do we find the total voltage? Okay, how do we find the total voltage? I'm still trying to send this, guys. Okay, this thing is delaying us, but we're going to continue now. Okay. Okay, so we are saying that uh, the current will be what? We are saying that the current will be constant, and then what will happen to the V total? So the V total, when we need to calculate the total voltage, this is the formula that we're going to use. The V total, this will be equals to what? How do we calculate the V total? This will be equals to, we need to take the voltage of the V1, we need to add it with the V2, we need to add this with the V3. So this tells us that the V total, we just find the sum of all those voltage. That's how easy this thing is. Then now look at this. We're going to have a current here. The same current that passed through that point is the same current that resistor 1 will read, is the same current that resistor R2 will read, and this is the same current that your R3 will read. So now what I'm going to say is that to find my total resistance, if the resistors are connected in series, so my R total, I just have to add those resistors. Like I just have to say this is my R1, I need to add this with R2, then this should be added with R3. So when you understand this information, trust me, the calculations will be easy for you. Trust me, the calculations will be easy for me. So what I need you to keep in mind is that when resistors are connected in series, we say that resistors in series are voltage dividers. Okay, so this is a notice. Resistors, your resistors in series, we say they are voltage dividers. Right, your resistors, thank you. Your resistors in series are the voltage dividers. So now what will happen if we have the ones that are connected? So this is series now. I'm going to explain what happens when the resistors are connected in series, in parallel. What about when they are connected in parallel? So I'm just gonna give you guys the diagram. So this is how it will look like when we say they are in parallel. Let's say we have V1 here. Remember that the voltage will be connected to what? The voltage will be connected to a resistor. So I'm just gonna put a resistor here, and we're going to call this my R1. This is my R1. Okay, so now from this R1, let's put another resistor. We're going to put another resistor here. Let's call this one R2. Okay, this is my R2, and then from this R2, maybe we can put R3 down there. So we know that this R2 will also be connected to a voltage which is V2. Okay, right. Then let's say I put another one on this point, or let's put a resistor here. this is my R3, and remember that this R3 will be connected to a voltmeter also. Let's call this V3. Right, so I think everyone now understand how this drawing goes now. So from this point I'm gonna connect this to the let's call this voltage the V parallel. I'll explain, everything will make sense now, né? So everything will make sense, don't worry. So what we need to understand here is how our voltage will move. We just have to study the diagram and indicate how will the current move. So current in parallel, the current in parallel divides. So that's one thing you need to understand about this one. The current in parallel, they will divide. I'm going to explain how the current divides, né? So that if you understand how the currents divides, everything will be easy. So now we are saying that the current in parallel, they divide. Right? I'll definitely explain how the currents divide. So now this is how the current divide. Let's say we have a current that passed through R1 like that. So this is my current that will go through R1, and then let's say we have another current going through R2 like this. Okay, then we're going to have another current that will go through R3. I'm going to explain how the currents divide now. So this one, we're going to call it the first current. We're going to call this I2, the second current, and we're going to call this I3. So now this is how the current divide. Whatever current that is going to pass through that point, whatever current that is going to pass through that point, we call it the total current. So this will be my I total, my I total. So this is how it moves. It's going to move in this way. It's going to move like this. It will move in that way. When it reaches this point here, it will divide into 3 parts. So I'll explain how it divides, because it depends on what? It also depends on the resistors, né? It depends on the resistors. I'll explain how it divides. So some current will go that side to supply R1, the other one will go to read on R2, and the other one will go to read on what? On R3. That's how the current divide. So now what I need you to understand is that what will be the total current equals to? Let's go back. Remember, in series the current is constant, so all the current passing through R1 and R2 and R3 is the same, so it remains constant. But what about if it is on parallel? It's going to divide. So now when you calculate the total current, your I total, what is this going to be equals to? We take the current one, we need to add this to the second current, we add this to the third one. But now the difference between the voltage, remember that time we were adding the voltage. So in this case, if they are parallel, what do we do to the voltage? We say the voltage remains the same. So now what we are trying to put this in simple term is that when series are connected in, when resistors are connected in series, we say that the voltage, the total V is equal to V1 plus V2 plus V3. But now when they are connected in series, what is the voltage equals to? So the V total will be equal to V1 is the same as V2, which is also the same as V3. So we are saying that the voltage this time is the one that will remain the same. You'll see everything will make sense when we work on past papers or when we do examples, né? So now how do we find the current? Remember the resistor. Remember this is in parallel, so we're going to call this 1 all over R parallel. We say this is equal to 1 over R1 added with 1 over R2 added with 1 over R3. This is just everything that you already know. You already know these things, nah? So listen, the total resistor when the total resistor of parallel combination, you see those ones that are parallel, the total resistor of parallel combination of resistor, always know that it is always less than the smaller resistor in parallel. I'll explain what we mean by that. Né? I'll explain what we mean by that. So if all resistors in parallel are identical, the current will divide equally. Know that, let's say, who's this? Who's this? Tandeka. Okay, Tandeka is saying that, sir, can you please share timetable? We miss sessions. Guys, for this week, I don't have any timetable. I don't want to lie. Tandeka, for this week, I don't have any timetable. But now, there's a program that we are currently trying to bring it on board. So that program, yes, it will definitely have a calculator. And if you are, a timetable. If you are part of that program, then that's when you're going to see the upcoming lessons, and we'll also add you on the system. Don't worry. Okay, don't worry, we'll also add you on the system now. So now that's when you can see the upcoming lessons and the topics that will be covered on that lesson. Okay, so we are saying that if resistors in parallel are identical, the current will divide equally in each branch. So once we are saying is that, for example, let's say this resistor is 2 ohm, this resistor is also 2 ohm, and this resistor is also 2 ohm. Whatever current passes through, if the total current is 6, each and every resistor will read what? 2, the current will be 2. So we are trying to say that the current will divide equally. I hope this makes sense, né? I hope everyone is happy with that, because now we are about to dive into examples. Okay, so now this side we said resistors in series are voltage dividers. What can we conclude about resistors in parallel? So the resistors in parallel will be current dividers. So we're going to say that the resistors in parallel are current dividers. Okay, I hope this makes sense, né? For everyone. I hope everyone understands this, né? Okay, I'm going to give you a drawing. Now, I'm just gonna give you a drawing. Okay, let's work on an example, né? Let's say that we have surprise. Thank you for the heart, né? Thank you. Okay, so this will be, I'm just gonna draw Just gonna put 3 resistors like this in parallel. Okay, let's put another one here. Let's put another one here. So these are my resistors. Okay. Okay, so now let's say this is given as 10 ohms, and then we have this as 5 ohms, and then we're going to have this as 2 ohms. Né? So now from this, what I'm going to do, I'll have the total current that will definitely divide. So I'm going to give you the total current here. I'm going to give you the total current. Let's do it like this. So the I total, my I total is given as 8 amperes. Né? 8A. So if it's 8A, we need to say that the current that will pass through that point, we're going to call this guy current 1, the first current. Né? And then the one that will pass through this one, we're going to call it current 2. The one that passed through that one, let's call it current 3. So now this is the only information that we are given, and they say that in the diagram below, determine the current in resistor 1, resistor 2 and resistor 3. If the total current is 8, we need to find the current. They say calculate the current, calculate the current, the current in R1, R2 and R3. So we need to make calculations to find the current in resistor 1 and the current in resistor 2. Okay, it's easy. Né? There are many methods that we're going to discuss here. Let's start with the first method. Maybe we can call this method 1, because someone might prefer method 1, someone might go with method 2. So it's up to you what you want to do. Né? That's up to you. You can choose any method you prefer. Okay, so now let's say that, remember this, these things they are in, we are saying that they are in what? In parallel. So I'm going to say, we said 1 over R parallel, it's equals to, so we are looking for the total resistance for these resistors because they are in parallel. Né? So this will be equals to 1 over your R1. We add this with 1 over your R2. We need to add this with 1 over your R3. Then we can just substitute 1 over R parallel is equal to 1 over R1 is 10. So I'm just going to say this is 10. You're going to add 1 over 5. We add 1 over 2. So if you punch this on the calculator, what do you guys get? What do you get when you work out all these problems? Can someone please assist there with the calculator? Tell me, what is 1 over R parallel equals to? What is that equals to? I need it in fraction. Eh? What do you get when we put it in fraction? Come on, can someone please assist? 4 over 5, okay? Surprise got 4 over 5. So this will be 4 over, surprise got 4 over 5. Thank you very much for your answer. Né? So I'm just going to write this down. I'm just going to write this as 4 over 5. Therefore, if this is 4 over 5, remember we need to find the reciprocal of this. So our R parallel will be 5 over 4. The reciprocal of that, when you punch this on the calculator, what is 5 over 4 equals to? When you punch it on the calculator, what do you get? What is that equals to? When you put it on the calculator, what is that equals to? $1.25. Thank you very much. I hope you did this right, ne? 1.25. So this will be 1.25. So I have my R parallel, which is 1.25. I have this as 1.25. So what's next? So if I have my R parallel, I can find my voltage. I can find my V parallel. I'm not sure if you still remember the formula that we can use to find V voltage. Ne? Let me write it like this. If I put it like this, this is what I'm going to have. I'll say that my R V parallel will be equals to, we need to take our current, we need to multiply with R parallel, because I think so far everyone understand the how this works, ne? How the formula works. So from this formula I can find my voltage. I can say V parallel is equal to I total, which was given as 8, multiplied by the R parallel of 1.25, because I need to find the V parallel. So if you multiply these two, we get okay, if we multiply these two guys, we get what? We get 10V. So this is my solution. This is my V parallel. So I am going to use my V parallel to calculate the required what? The required current. Let's start with R1. So I'm going to say that the current of this one will be, the formula for current is V parallel. We need to use the parallel voltage over what? The parallel voltage over R1, because we are doing for R1. What is this equals to? The parallel voltage, we just calculated this to be 10, and this will be 10 divided by 10. So therefore, the current for the resistor 1 is just 1 amperes. I think everyone understand how we got that one, eh? And we're going to repeat the same process to find the one for I2. We say the V parallel divided by the R2. So my I2 is equals to V parallel is 10 divided by the resistor 2, which is 5. So this is 5. Now what is the current? Is just 2 amperes. Then we need to repeat the, look at this. Already we have 1. Already we have 2. So this tells you that the current 3 will read what? The current 3 will read a resistor of 5. But let's try and prove this. Ne? I3 is equal to V parallel over R2 or R3. If we substitute, our R3 is equal to V parallel was given as 10 divided by, this should be 10 over 2. So if it's 10 over 2, therefore what is I3 equals to? That is just 5 amperes. So now I'm going to conclude. I'm going to put a conclusion and say, I know that this one will read what? 1 ampere. This one will read 2 ampere, which is 3 in total, and this will read 5 in total. So now look at the total. The total, the I total, it's equal to 8. This is how the 8 divides. The 1 ampere will go that side to read on the resistor 1, and then we have the 2 that will go to read on the resistor 5, and we have the 5 that will go to the resistor 2. So in conclusion, the resistance, that is the smaller resistance, will read a bigger current. I'm not sure if when I say it like this, everyone will understand. né? I hope everyone understand that part. Yes, that's how easy it is to find the current of what? To find the current of each resistor. First thing first, we need to find what we need to, because these resistance are in series, we need to find the total resistor, and this is the formula for finding the total resistor. While you have the total resistor, you use that total resistor to find what, because we have the resistance, we have the total current, we can find the V parallel. Then we're going to use the V parallel to calculate the current of each resistor. I hope this everyone is happy with that, né? Okay, I hope everyone is happy with that. There is another method that we can use. So the other method that we can use is like the formula. If we do this second method, the formula that we can use, it's like saying we know that the current, if we call it Ix, is going to be the total current, I total. We need to multiply this with the R parallel, divide by what? Our Rx. That is the formula, that is the other formula that you can use. But now, if we use this formula, remember this is my I1, it's equals to I total. We were given the total current, which was 8. Then we need to multiply this with the R parallel, which is the one that we just calculated as 1.25. So this will be 1.25 divided by Rx. Rs, we need to substitute our resistor. So this is for the first one. So this is my R1, this is my R2, this is my R3. So now R1 is 10, so I'm going to divide this by 10. Where there's Rx, I'll divide this by 10. When you punch this on the calculator, you should get the same answer that we did on top. We can say this is 1 amperes. So to find the second current, we know that the total is 8, and then this will be 8 multiplied by the 1.25. So the 1.25 doesn't change. The only thing that changes on this formula is your Rx. What is Rx? We are looking for the resistor 2, which was 5. So I'm just going to substitute that as 5. We should get the same answer of that 2 amperes. So if we find for R3, we use the same formula. This will be 8 multiplied by 1.25, everything divided by Rx, which is just 5. So when you punch this on the calculator, you should have your R3 to be what that we got that side, which is 5 amperes. That's how easy this thing is, né? Okay. So remember, there are a lot of equations that you need to understand when it comes to currents, but we'll keep on discussing those equations as we move. We'll keep on discussing those equations if we move, and if there's something that you don't understand now on this live lesson, you'll have a chance to go and watch the recording next. So now let's put this to be more interesting, because let's say you remember in an exam they can bring it like this. Most of the time they like including internal resistance, but for now we are not yet talking about the internal resistance. The most important thing about this lesson is for you to understand how the parallel and the series resistors work. So if I have something like this, and let's say these two, let's say these two guys, they read the same voltmeter. Let's say they read the same voltmeter, and then now this side we're going to have two resistors that are in parallel. So this will be my resistor here, and this will also be my resistor there, and then they will read a current that will call it amperes. Then I'm sorry about the drawing, but I think everyone can see the drawing now. So from this, let's say that we are given the total voltage. Let's say the total voltage, let's say this is 12 and then I have this S6. Let's say this is 10, this is my 6, and this is given as 48V. 48V. So now, in which direction, I need someone to tell me in which direction does the conventional current flow? In which direction will the current flow? How do we see that the current, how do we see that the current is moving? Because they might give us something like this, and they expect you to tell them in which direction is the current flowing, with a reason, of course. If you still remember, the current flows from, it will start from a positive. It will start from positive, and then it will move to what? To negative. So it moved from positive to negative. That's how the current flows, right? From positive to negative. So we know that if the current move from positive to negative, thank you, positive terminal, from positive terminal, surprise, thank you very much. So if it moves from positive to negative, now the next question that you need to tell me is that in which direction do electrons flow? How will the electrons flow? Because if the current moves from positive to negative, the electrons will do the opposite of that. The electrons will move from negative to positive. Right, let's do some calculations. Now let's use this diagram to make some calculations. Let us calculate. Okay, let's calculate the total resistance of the current. I want us to find the total resistance. I want us to find the R total. How can we find the total resistance of this current? We just have to first identify the resistors that are connected in series. So maybe I can say this is my R1, this is my R2, this is my R3, and this is my R4. So now, which resistors are connected in parallel? Because we need to first find 1 over R parallel. So say, is that 40 or 48? This is 48, né? This is 48V. Right. So there is only 2 resistors that are connected in parallel. It's R1 and R2. Exactly, R1 and R2, those are connected in parallel. This will be 1 over R1 is 12. We need to add this to 1 over R2, that's 6. So if I have this 1 over R parallel, we can work this thing out. This will just give us 1 over 4. So this will just give us 1 over 4, because if this is 1 over 4, look at this, we can multiply top and bottom by 2, then the denominators will be the same. This will give us 2 over 12. Wait, oh, not 2 over 10. We said we'll multiply both 2 and 3, which will give us 4 over 12. 4 goes into 12 4 times. This will be 1 over 4. Then our RP will be the reciprocal of that, which is 4. So this is the total resistance of those ones that are connected in parallel. It will just be 4 ohms, like that, né? So this is my answer. Right, what's next? And now to find our R total, né? To find our R total, we can say that the R total is equal to, we need to take that R parallel, we need to add this with R3, we add this with R4, because the R parallel, what I'm trying to say is that these two parallel, we combine the sum of these two, whatever sum that we get, it will be in series with what? It will be in series with R3. Why? Because remember, whatever current that passed through that point is the same as current that passed through that point. So this tells you that your R parallel will read the same current as R3 and R4. So they are in series. So to find the R total, we need to take the 4, we need to add with R3, which is 10. We add with R4, which was given as 6. So the R total for that will be 4 plus 10. It's 14 plus 6. This will give us 20 ohms. And that's it. Thank you, Evelyn. And that will give us 20 ohms. Right. So if we have that, we can be able to determine the reading on the ammeter. So the reading on the ammeter, which is this one, the ammeter, that guy will read the total what? The total current. The ammeter, that guy will read the total current. So how can we work this thing out? How can we find the total current? Remember, the formula that we can use is the current is equals to V over R. So we know what is the voltage. It was given as 48. Divide by R. We use the R total, which is the one that we just calculated, 20. And this is how easy the problem is. Your current will be 48 over 20, which will give us, we know that 20 goes into 42 times, comma, then we have a remainder of what? A remainder of 8. So the remainder of 8, half of 8 is just what? Half of 8 is 2. This will be 2 comma 4. So this is 2 comma 4. This is the current. This is the I total. So the amperes A, that A will read the total current. Right. So now, thank you very much, Surprise. I see you got it right, né? Thank you very much. I see that you got this one right. Okay. So now what will happen is that we're going to say that on this problem we have what can we do from this? Okay, let's answer the last question. Let's answer the last question on this one. Then tomorrow, so that we can start working on internal resistance. So let's say we need to find the reading on the voltmeter. This voltmeter, the reading on the voltmeter. We need to find the reading on this voltmeter. So remember that the voltmeter, it is for the what? Is for the resistors that are connected in series, the R4 and the R3. So we'll have to add those two. That's the total one that we're going to use. So what I'm trying to say, we know that we can calculate V. Yes, we can calculate V surprise. This is what we're gonna work on. So this is what we're gonna work on. So look at this. We're going to say that V2, thank you for the heart. Okay, so we're going to calculate it like this. We're going to say V is equals to I over R. Where is this formula coming from? We just worked around the original formula, and then we made what? We said I is equals to V over R. We made V subject of the formula by multiplying this side by R, that side by R. Therefore, what is V? V is just current times the resistor. But now look at the resistor. We are looking for the sum of what? The resistance that are connected in series, which is the R4 and the R3, because you see that V is connected to R4 and R3. So now when it's R4 and R3, we're going to say this will be in this form. I have my voltage. What is the voltage? Is the one that we are looking for. V is equal to the current. The current. So it's very important that the current that we use is the reading on ammeter, is the total current. So we just calculated the current as 2.4. I'm going to substitute that as 2.4. the resistor, we need the R total, but for those that are connected in series, which is 6 and 10. So this will be 6 plus 4, which gives us 10. So 6 plus 4, wait, is it 6 plus 4 or 10 plus 4? Okay, it's 10 and 6. I'm sorry, it's 10 and 6. So we're going to add the 10 and the 6. Oh, shucks. Okay, we're going to add the 10 and the 6. Let me just... Okay, so we're going to say this is 10 plus 6. I think everyone now understand why are we adding the 2. Then the voltage is equal to 38.4 V when you put it on the calculator. Thank you, Evelyn. Yes, surprise. I see that we were supposed to say for 16 ohms. Nah? Okay, guys, this is where we're gonna stop, because remember, we just wanted to do an hour, 2 hours on YouTube, 1 hour on TikTok, né, for physics. So we did 51 minutes, that's close to an hour. And then tomorrow on circuits, we'll definitely continue with working on what is this, the internal resistance. That's it from me today. If you guys have any questions, I'll just give you guys seconds to ask your questions before we can end the live. You guys have any questions? Say if there was another voltmeter on the parallel resistor, could we calculate it as 48 minus 38.4? If there was another voltmeter on the parallel resistor, yes, we can definitely do that. If they are parallel, remember we said that there was this, we said resistors, no, you said if they are parallel. No, if they are parallel, we're going to say that voltmeter, for parallel voltmeter, we said resistors in parallel are current dividers, but look at the voltmeter will remain the same. So what we are trying to do is that if our V is 38.4, this tells you that whatever other, if we have other volume, where is that diagram? If we have other V for the series, this R will read the same voltmeter as what? As our R2. So we can't say that one, but it's fine. Okay, let me quickly go back up just to make sure I give you the correct answer. Remember we said V total for series, we add them. V plus V1 plus V2. But when they are in series, what is that? When they are in series, we say that the V total, they remain the same. For series, for parallel, they remain the same. For series, we add them. V1 is equal to V2. Yes, surprise. Thank you for the gift, guys. Thank you. This is where we're going to stop. So we can plan on that program of ours and see how many learners we can get on the program. Thank you very much. I'll see you guys on the next lesson. Let's meet tomorrow, 8 a.m. Thank you, Surprise.